Okay, so now let us take the last type of function, and that is called inverse function. The name itself is saying inverse function. So therefore, it does exactly opposite to what the function does. Let us understand what is inverse function through this example. So here we have set x and set y, and the function f is mapping from set x to set y. So set x is the domain of this function and set y is the codomain of this function. In the domain of f, elements are x1 and x2, and these are being mapped to y1 and y2 under f. Okay, fine. Now, I just told you that inverse function does exactly opposite to what function does. Okay, so f is being mapped from x to y. So if you are talking about inverse function, then that will map from y to x. So what is happening here? We are interchanging the domain and the codomain. Next, f of x1 is equal to y1, right? That is what is being shown here. Now, f inverse of y1 will be x1. What is this? F is taking x1 to y1. F inverse will take y1 back to x1. Got it? Exactly opposite. Mapping is like this for f. For f inverse, mapping will be like this. Mapping is like this for f. For f inverse, mapping will be like this. Okay? So, in the same way, f of x2 is equal to y2 implies f inverse of y2 will be equal to x2. Okay? Till here, we are just doing the exact opposite to what f is doing. Next, if I consider the composite of f and f inverse, then what will happen? Let us take f inverse circle f. F inverse circle f. Now, this is a composite function. Now, before we go forward, let me tell you some things. F inverse is not equal to 1 by f. Okay? This is just a way of writing to show that f inverse does exactly opposite to what f does. Okay? So don't mistake and write like 2 power minus 1 is equal to 1 by 2. This is not what, we have here when we write f inverse. Next, from the understanding of composite functions, I'm sure you remember that. So let us consider the composite function f inverse circle f. Okay. So from the knowledge of composite functions, we know that for a composite function, the domain is decided by the inside function and the codomain is decided by the outside function. I hope you remember this. We have discussed this in composite functions, right? So here for f inverse of f, for this function, the domain will be decided by the inside function. That will be f. So therefore, the input for this function should come from set x. So let me write x here. And now, whatever f does, f inverse does exactly opposite to what f does. So therefore, I can say that whatever is f doing, f inverse is nullifying. So therefore, whatever is my input, the same output should come. Of course, this x should belong for all x belonging to set x. Okay, the input is coming from set x. Next, in the same way, f circle f inverse, the domain should come from set y. Because the domain of the composite function is the domain of inside function. So here, let us write y. And in the same way, whatever f inverse does, f will cancel it out. So therefore, again I will get y here. For all y coming from, the inputs are coming from domain of f inverse, and domain of f inverse is y. And the domain of f inverse is y. Okay. Now, let us see how this is happening. I told you theoretically that whatever f is doing, f inverse is cancelling it out, right? And so therefore, we are getting x. Let us do it mathematically. F inverse of f of, let us say x1. Because this x has to come from set x. So let me consider x1. So what is f of x1? Here we have written that is y1. What is f inverse of y1? That also we have written here, and that will be x1. So clearly we can see the input is same as the output. In the same way, if I replace x1 with x2, here I will have y2, and again I will have x2 here. F inverse of y2 is x2. So again you can see the input and the output both are same for this composite function of f and f inverse. So in the same way, let us do it for this also. F inverse of, take an element from set y, let us say y1. So f inverse of y1 is nothing but x1. F of x1 is nothing but y1. And similarly for y2. So on the whole, we understood that whenever you take a composite function of a function and its inverse, then that will be an identity function. That will be an identity function. But these two identity functions are different. Why are they different? They are different because they are defined on a different set. This is identity function on set x. This is identity function on set y. So the same thing we can write like this also. So this was the proof of the composite of f and f inverse to be identity function. So after this, we can write this one, and that will be f inverse circle f is an identity function in the domain of f, and that is x. And f circle f inverse is an identity function in the domain of f inverse, and that will be y. Okay. So these are the important points. What are the important points? These ones. So what will happen to the domain and codomain? They get interchanged. Next, whatever f does, f inverse does exactly opposite. And so f of x1 is y1, then f inverse of y1 will be x1. Next, composite of f and f inverse will be an identity function. Okay, and this is the extension of the same thing. So 3 important points in inverse functions. Okay, fine, very good. So means what we are saying here is, for a function, if you can find a function in such a way that the domain and codomain are interchanged. Again, for a function, if you can find a function, let us say g. Okay, for a function, if you can find a function g where the domain and codomain are interchanged, and when you take the composite of these two functions f and g, if you get identity function, then this function g is inverse function of f. Okay, you will understand very clearly when we do some problems. But on the whole, it is very simple, right? For a function, if you can find another function where the domain and codomain are interchanged, and the composite of this function and this function, f and g, that is f circle g and g circle f. If these two are identity functions, that means that this g is inverse function of f, right? Simple. So this is how we test if a function is invertible and what is the inverse function. Let me, you will understand very clearly. There are some functions which are not invertible. Okay, so there are some functions which are not invertible also. Okay, so there are some functions which cannot be, means you cannot find the inverse of that function. I will tell you the reasons when we do a question in the same video little later. Let us not complicate it right now. Let us just understand that there are some functions for which the inverse function does not exist. There is no function for which if you interchange the domain and codomain and you take the composite of f and g, then you will get identity function. So there is no g like that. Okay, so there are some functions which are not invertible. We will discuss that little later. But for now, if a function is invertible or not, to check that, we have to find a function g which is interchanged, which has its domain and codomain interchanged, and the composite function should be identity function. Of course, these two are different identity functions. This comes from the domain of g, and this you can say comes from or defined on. So this is an identity function defined on domain of g set, and here domain of f set. Okay, so simple, right? Okay, so let us go ahead. Inverse function, okay? A function f maps from x to y is defined to be invertible if there exists a function g mapping from y to x. Okay, so interchange the domain and codomain such that the composite function is an identity function, and this identity function is defined on domain of f, and that is x, and f circle g is equal to iy. The function g is called the inverse of f and is denoted by f inverse. Okay, if you can find such a function, then that will be our inverse function and it will be denoted as f inverse. Okay, so let us do one problem. How do you find the inverse of a given function? Let f maps from n to y be a function defined as f of x is equal to 4x plus 3, where y is a set, this y is a set where y belongs to natural numbers and y is equal to 4x plus 3. Okay, for some x belonging to natural numbers. Show that f is invertible and find the inverse of f. Okay, so these questions means finding inverse questions are very important as far as boards are concerned. Okay, why? Because they are a compulsory question which come in long answer questions. So you have to give a very detailed way of finding the inverse function. Okay, there is a specific 5-step procedure which is same for all of the functions of finding inverse. So if you understand it for one problem, then the same thing you have to write for all the problems, just you have to change the numbers and the function, whatever is the given function given in that question. Okay, so as I told you, this is very important from board's perspective. And of course, from competitive exam perspective also, inverse function, finding inverse is important. Okay, let us come back. Let f map from n to y. So this is our domain and this is our codomain. Be a function defined as f of x is equal to 4x plus 3, where set y is containing elements y belonging to natural numbers such that y is equal to 4x plus 3 for some x belonging to n. Okay, so here we have the information of what is set y. Okay, fine. Next, show that f is invertible and find the inverse function of f. Okay, so now, first of all, there are some important points. Finding inverse of a function is a compulsory question which comes in boards. So therefore, understanding the way you need to write is also very important from the board's perspective, because this is a long answer question. You have to write it in a stepwise manner, and only then you will be getting all the marks. So follow the steps which we are using here, which we are writing here, and write it exactly like that for any problem of inverse function. The way you write is exactly the same, but you have to follow this format. Okay, that is the first important point. Next important point is, why are they defining such big set y, all of this y belongs to n? It looks a little complicated. Y is equal to 4x plus 3 for some x belonging to n and all of that. Now, this part of this explanation which I am giving, if you are preparing for boards, you can absolutely forget it. There is no problem at all. You can proceed with the solution without even considering what is this set y. Okay, and you will be getting all the full marks, and there is no need to understand what is this set y, why it is given and all of that. But if you are preparing for competitive exams, then this maybe 3 or 4 minutes part of the video, you have to understand it. Okay, now just before I told you that there are some functions for which inverse function does not exist. Why? Something like this. Let us take some cases a and b. Let us say the function f is mapping from a to b and the elements are like this: a, b, 1 and 2. The mapping is something like this. Okay, next let me show you one more: a to b and a, b, 1 and 2. Okay, so let us say 3 is also there here. Okay, the mapping is like this: function f. Okay, f1, f2. Next, a, b. Okay, a and b are there here, 1 and 2 are there, and Okay. So let us say only 1 is there here. And the mapping is like this. This is F3. Okay, so now let us understand. Okay, for this function, if you are taking the inverse function, then it will be mapping from B to A. Okay, and this is the inverse function. So what are the elements in B? 1 and 2. Here A and B. 1 will be mapped to A and 2 will be mapped to B under inverse function of F1. Okay, now is this a function? Inverse function is also a function. Is this a function? Is this a function? Every element of domain should have exactly one image. Is it happening? Go element by element. 1 has exactly one image. 2 has exactly one image. So therefore, F inverse will be a function and it will be defined for this function F1. Okay, fine. You will be able to better appreciate when we discuss these. So let us take set B here and set A here. We are talking about F2 inverse and 1, 2, 3, A and B. The mapping is from 1 to A, 2 to B. This is F2 inverse. Now, is F2 inverse a function? Let us see. Now, every element of domain should have exactly one image. So here, 1 has exactly one image, very good. 2 has exactly one image, very good. And what about 3? 3 does not have exactly one image. So therefore, this will not be a function. So therefore, for this function, inverse does not exist. Inverse does not exist for this function. Why? Because you have seen very clearly, it is not following the rule of the function. So therefore, if you have the function where one element is left over in the codomain, means this is not an onto function. Codomain is not same as range. So therefore, if codomain is not same as range, that means if it is into function, then inverse does not exist. Inverse does not exist. Inverse does not exist. Simple. Why? Because codomain will not be equal to range and means there are some elements left over here. Means when you take the inverse function, this element will not have any mapping. So therefore, this will not be a function. Okay, fine. Let us go to the next one. Here, this is F3. If you are taking F3 inverse, then this will be mapped from B to A. F3 inverse. And 1 is there here, A, B, and you have 2 arrows coming out. Now, is this a function? I am sure with this amount of exercise that we have done, you will be able to say that this is not a function because from every element should have exactly one image in the domain, which is not happening. So again, we have a problem. Here codomain is range, no problem. This is an onto function, no problem. But you have 2 arrows coming out. That also is not allowed for a function. So what to do now? So if here, this is many one function. Okay, let me write MO, many one function. So if it is a many one function, then the inverse will have two or more arrows coming from some elements. So again, that is a problem. So our function should be 1, 1 function as well. Okay, only then inverse exists. Not only this means not only 1, 1 function, it should be onto function also. You can come to this one. This is 1, 1. This is onto. So therefore, inverse exists. Okay, got it? So that is why the codomain, they are saying is equal to the range. Okay, y contains natural numbers such that y is equal to 4x plus 3. What is y is equal to 4x plus 3? That is nothing but the output values of the values in the domain. So therefore, y contains only those elements which are outputs of 4x plus 3. So therefore, this is a onto function. So to make this onto function, they are taking set y here and not set n. Okay, fine. Okay, so we will take one more problem. There you will be able to understand very well. On the whole, what did we understand? If it is a many one function, then when you take the inverse function, more than one arrow will come out of some elements in the domain. Next, if it is not an onto function, there will be some elements which do not have any arrow coming out. So to have only one arrow coming out of every element, this function should be bijective. This function should be bijective. Only a function which is bijective will have its inverse function. Okay, fine. Okay, so this is a very important point. F inverse exists only if F is bijective. Only if F is bijective. Okay, so till here, as I told you, it will take some time to discuss for which functions inverse function exists. Okay, so after this, it is just the normal method in which you have to write for board exams. Let us write. Let y be any arbitrary element in range of f. Okay, so this will be the first line. Let y be any arbitrary element in the range of f. Y is equal to whatever is this function, 4x plus 3 for some element x in domain, and that will be n. Okay, for some element x in the domain, y will be 4x plus 3. Okay, next, this will be our step 1. Okay, next, step 2. Step 2 will be get x as a function of y. So here we have y as a function of x. So y is equal to something is there. When I say x should be a function of y, x should be there on one side, everything else should be there on the other side. And that is very easy in this question. Just get 3 on the other side, so y minus 3. So 4x is equal to y minus 3. So x is equal to y minus 3 divided by 4. So step 2 is completed. Okay, what is step 2? Get x as a function of y. Next, step 2 is done. Let us write step 3. In step 3, we have to define a function. Let us define a function g such that for this function, the domain and codomain should be interchanged and written. So here n to y, right? So therefore here y to n, such that g of y is equal to this expression. Okay, so y minus 3 by 4. So what have we done here? Ultimately, whatever is the given question, we have expressed x as a function of y and we got something, right? So this should be taken as our new function. Okay, and for which the domain and codomain should be interchanged and written. Okay, simple. Next, step 4 will be find g circle f of x and f circle g of y. Okay, this has to be done in step 4. We are finding out the composite of g and f and seeing what we are getting. Okay, so in all of the questions in boards, you have to get these two as identity functions. It will certainly happen. If it is not happening, that means you have made some mistake, but otherwise it will certainly be an identity function. Okay, so consider g circle f of x. Okay, so g of f of x. Okay, g of what is f of x? That is 4x plus 3. Okay, so g of 1 will be 1 minus 3 by 4, right? So g of 2 will be 2 minus 3 by 4. So whatever is there here, that should be put in place of y. So g of 4x plus 3 will be 4x plus 3 minus 3 divided by 4. Okay, so 3 is getting cancelled. 4x by 4, which is equal to x. So what did we get here? G of f of x is equal to x. Okay, next line will be, always you will get this as an identity function. So just you have to write it in the, after this will be g circle f of x is equal to x for all x belonging to, this x come from domain of f. Domain of f is n. For all x belonging to n. Okay, implies g circle f is an identity function on set n. Okay, this is very important. This you have to write after finding G circle f of x is equal to x. Right, G circle f of x is equal to x for all x belonging to domain of f, and that will be n. So therefore, G circle f is an identity function defined on. Okay, so this will be one thing, that is finding G circle f is an identity function. Next will be, the story is not yet completed. We should find f circle G of y. Why do we have y here suddenly? Before we had x, right? G circle f of x. Here we have y. Because in G circle f of x, we will have g of f of x. And in f circle G, we will have f of g of something. So this should be y, because we have defined g of y. Okay? So simple. So therefore, f of g of y. Next, f of, what is g of y? We got y minus 3 divided by 4. Okay. So f of x is 4x plus 3. F of this thing will be, just replace x with this whole thing. So 4 into y minus 3 divided by 4 plus 3. So 4 is getting cancelled. So y minus 3 plus 3. So this is equal to y. So similarly, the way we have written for G circle f, you write it here as well. What did we write? F circle G of y is equal to y for all y belonging to domain of G, and that will be y. So therefore, f circle G is an identity function on set y. So this completes our step 4. In step 4, we have to find the composite function, and we have to show that this is an identity function. Okay, exactly this way you have to write. Okay, these things should never be mentioned, should never be forgotten. Okay, so that's it. So after this will be step 5. So step 5 will be hence G circle f is an identity function on domain of f, that is n, and f circle G is an identity function on domain of G, that is y. So what did we get here? We found a function G whose composite function with the given function is an identity function. So therefore, f is invertible implies f is invertible, and G of y is equal to f inverse of y is equal to y minus 3 divided by 4. Okay, so this is the board's format of proving that f is invertible. Okay, so before I taught you f should be bijective. That is for understanding purpose, and that is for competitive exam purpose. But as far as boards is concerned, you should find the composite function and prove that that is equal to an identity function. And that's it. So after that, whatever is this G of y will be our inverse function. Okay, so now let us write the step-by-step procedure, the 5 steps which have to be followed in all of the questions. So the 5 steps are something like this. Step 1. Consider an arbitrary element y belonging to the range of f. This is a common line in all of the solutions of inverse function. Okay, so this will be a common line. Okay, in step 1, then y is equal to f of x for some element x in the domain. Before, if you remember, we wrote y is equal to 4x plus 3 for some x belonging to n. Got it? So the same thing here. So this box will change with question, but everything else will remain the same. So y is equal to this function f of x for some x in domain. So this domain set will also change. Here it was natural number set. Okay, next is step 2. Get x as a function of y. Means you have to have x on one side and everything else on the other side. So what will be that everything else on the other side? It will be some expression of y. Okay, so this box will change with question, but otherwise the way you write will be the same. So get x as a function of y means x should be on one side and everything else should be on the other side. So this you won't be writing. This is for understanding purpose. This is how you should get in step 2. Okay, so step 2 is done. Okay, next step 3. Let us define a function g. In step 3, what are we going to do? We are going to define a function g. And how are we going to do it? You are going to interchange the domain and codomain with the given function. So before it was from n to y. So in g it will be from y to n. So codomain of f will come here, domain of f will come here. Okay, fine. So by g of y is equal to some expression of y. What is this some expression of y? Just before in step 2, we got x as some expression of y. This box will come directly here. Okay, if you remember the question which we have done, x is equal to y minus 3 divided by 4. And in step 3, when we wrote g of y is equal to y minus 3 divided by 4, the same thing has come here. Okay, fine. So the next will be step 4. Now find g circle f of x and f circle g of y. If you're doing all of your calculations right, you will get this 2 as identity functions. Okay, it is compulsory. You have to get it. We should get these 2 as identity functions, and this will be an identity function defined on domain of f. So therefore, if you remember, we got in here and iy here in the previous question. So these things will change, but the way you write should be the same. Domain of f and domain of g. So you have proved the composite function of g and f is an identity function, and therefore this says that f is invertible. So hence g circle f is an identity function and f circle g is an identity function, implies that f is invertible and g of y is equal to f inverse of y is equal to whatever was that some expression of y. You are getting this from step 2, and in step 3 also you have the same box. That same box will come here. Okay, fine. Okay, so I hope that you have understood the 5-step procedure. Let us go back and revise once again so that there should not be any doubt. This line is common. Then y is equal to the question for some x in the domain. Get x as a function of y. This some expression of y will come in step 3. It will come in step 5 also. Okay, next will be step 3. Here you define a function g. You interchange the domain and codomain. And g of y will be whatever you have found out in step 2, the sum expression of y. Next, after that, step 4, find the composite function and prove that these 2 are identity functions. Next will be, hence, because you got the composite function to be identity function, implies that f is invertible and g of y is equal to whatever is there in our step 2 and step 3, write it here. Some expression of y, whatever was that. So in the previous question, we got y minus 3 divided by 4. Okay, so let us take one more question, and this is more important than the previous question. Okay, so what is there here is, let f maps from n to r be a function f of x is equal to 4x square plus 12x plus 15. Show that f maps from n to s, where s is the range of the function, is invertible. Find the inverse of f. Okay. So here there might be little confusion. F maps from n to r is given, and later show that f maps from n to s is invertible. Whenever you have such a question in boards, you don't need to think much. You have to just forget about this. We have to show that this function is invertible, and what is f of x? This one. Okay. So you have just changed the codomain, but everything else is the same. 4x square plus 12x plus 15. Okay. What did I tell you? When you have something like this, f of x is given, and suddenly show that f maps from n to s, okay, is invertible. So just forget about this and proceed. Okay, and in the last I will tell you what is being done here. Okay, why they have changed. That is not so important. So step 1, how do you write it? As I told you, this is an important question. Okay, understand this very well. These type of questions come in boards. And this is very important from the competitive exam perspective also, some part of it, I'll tell you. So the first line will be same. Let y be any arbitrary element in range of f. Okay, this is the first line. Y is equal to 4x square plus 12x plus 15 for some x belonging to domain of f, and that will be n. So write n here. Okay, so this is what is step 1. Next, step 2. This is important from competitive exam perspective. Okay, fine. So what are we going to do here? we are going to get x as a function of y. Okay, so we have a quadratic here. Before it was linear, so it was very simple. What is linear? Linear means highest power of x is 1. So x is equal to y minus 3 by 4, very simple. Here, how do you do it? This way of doing is very, very important. The way you do is something like this. 4 into, take the coefficient of x square out and make it as 1. So 12 by 4 into x plus 15 by 4. What are we doing here? We are making the coefficient of x square 1. Next, 4 is there outside. So this is 3. So now we have x square plus 3x plus 15 by 4. Okay. Now, always whenever you have the function to be quadratic, make it as a perfect square, because of which your simplification will become much easier. Okay. So what is meaning of perfect square? First, you make the coefficient of x square 1. Next, write x. Take half of coefficient of x along with sign. That is 3 by 2. How? Coefficient of x along with sign is plus 3. By 2 will be plus 3 by 2. Whole square. Outside, write minus b square. Whatever is b square. Okay. Here it is 3 by 2 whole square. Okay. If you had minus, let us say. Okay. You had x square minus 3x. So here you will have minus 3 by 2. No problem. Even then you will have minus outside and b square. What will be b square? That will be 3 by 2 whole square, right? 3 by 2 whole square. Okay. What I am saying is, here plus is there or minus is there does not make any difference. Here minus will come. Here whatever number is there, square it and write it here. Okay. Fine. So plus 15 by 4 is there as it is. Now, how did we get this suddenly? What is this that we have learned just now? 4 is there outside. Because of this, use a plus b whole square. So a square plus 2ab. Okay. So x square plus 3x, because 2 is getting cancelled. So x square plus 3x. Okay. So this much is what we have. Plus b square. That will be 9 by 4. So this much I want. This is extra. So therefore, outside of this, I am putting minus 9 by 4. That is minus 3 by 2 whole square. Plus 15 by 4 is there from before. So therefore, I am keeping it as it is. So what have I done? I have made this part as a perfect square. To make this as a perfect square, I have written like this. In this, extra plus 9 by 4 is coming. So therefore, I am doing minus 9 by 4. Okay. Plus 15 by 4. Again, I am telling you, always put a minus sign. Forget about if you have minus 3 by 2 or plus 3 by 2. Put a minus sign and write b square. Let me show you here. If we had x square minus 3x, x square minus 3x. This I want to make it as a perfect square. Make the coefficient of x square 1, which is already there. So therefore, write x, take coefficient of x along with sign, divided by 2. Put a square. Put a minus sign, b square. Now you can see. A square minus 2ab plus b square. Okay. So, and minus 3 by 2 whole square. So this is getting cancelled, and this is what is x square minus 3x, which is there here. So all in all, what we have understood is, if you use a minus b whole square or a plus b whole square, there will be plus b square only. Never you will have minus b square. So therefore, because plus b square will be there, you will do minus b square all the time. Okay, fine. This is very, very, very important manipulation from the competitive exam perspective as well. So 4 into x plus 3 by 2 whole square minus, here you have 9 by 4 plus 15 by 4. So this can be written as x plus 3 by 2 whole square, and 15 minus 9, that will be 6. So therefore plus 6 by 4. Okay, fine. So still step 2 is not completed. In step 2, we have to express x as a function of y. Here still we have y as a function of x. But this is very, very, very important. We have to do it before we find x as a function of y. Okay, so what did we get here? X as a function of y. Okay, first y as a function of x in terms of perfect square. 4 into x plus 3 by 2 whole square plus 6 by 4. That will be 3 by 2. Okay, fine. So for further part of the question, this will be our f of x. We will never be using this as our f of x, 4x square plus 12x plus 15. So what did you understand? When you are finding the inverse function and the function is quadratic, first make it as a perfect square. So this will be my f of x and only on this I will be working. Okay, fine. Okay, so now let us go ahead. So if you are multiplying this 4 inside, or you can divide it, that's okay. So y by 4 is equal to this whole thing, x plus 3 by 2 whole square plus 3 by 2. You can bring this here. So therefore, what are we going to get? Y by 4 minus 3 by 2 is equal to x plus 3 by 2 whole square. So if you are taking LCM here, then 4 will be the LCM, and on the numerator we will have y minus 6 is equal to x plus 3 by 2 whole square. After this, so where are we proceeding? X as a function of y. So x plus 3 by 2 whole square is equal to y minus 6 by 4. If you are taking square onto the other side, then you will have under root and plus or minus. So x is equal to minus 3 by 2 plus or minus under root of y minus 6 divided by 4. So we should get x as a function of y. But here we are getting x as a function of y and two different definitions. X is equal to minus 3 by 2 plus under root of y minus 6 by 4, and x is equal to minus 3 by 2 minus under root of y minus 6 by 4. Which one to take? Now, look at the domain. Domain is natural numbers. Natural numbers are positive integers. Can they be negative? No. So here, if I take minus 3 by 2 minus under root of y minus 6 by 4, this whole thing, this is negative, minus 3 by 2, this is also negative. So negative, negative, that will be negative, right? So therefore, we are going to rule out minus, minus, and we are going to take plus. Okay, how do you decide which one to remove? Very simple. Look at the domain. Domain is saying natural numbers. Natural numbers means positive. Here, if we take both negative, this will be negative. So therefore, we are not going to take that, and we are going to take implies x is equal to minus 3 by 2 plus under root of y minus 6 by 4, as x belongs to natural numbers, implies x cannot be negative. Cannot be negative. So here we have mentioned why we should not consider negative values of x. Okay, so therefore we have ruled out one definition, and always you should have x as one definition of y, not multiple definitions of y. Okay, so therefore x is equal to minus 3 by 2 plus under root of y minus 6 by 4. So x as a function of y, we got it. So therefore step 2 is completed. Okay, fine. So step 2 is very, very important. Here you will make y as a perfect square, and then you will find x. Okay, next step 2 is done. So what did we get y as? 4. If you are taking common, you got 3 by 2 whole square and plus 6 by 4, that is 3 by 2. This is what we got. Okay, so and x we got it as minus 3 by 2 plus under root of y minus 6 by 4. Okay, so now step 3. Let us define G mapping from, just shift the domain and codomain. So S will come first, N will come later. Again, I told you, forget about this. Always we are working only on this. And f of x will be not this one, it will be this one. Okay, fine. So such that g of y is equal to some expression of y. What is that some expression of y? X is equal to some expression of y. So therefore minus 3 by 2 plus under root of y minus 6 divided by 4. Okay, step 3 is completed. Next step 4. Step 4 will be consider G circle f of x, which will be nothing but G of f of x, which will be nothing but G of, what is f of x? This one, not this one. Okay, this one. by which your calculations will become much faster. You will understand in just a moment. Whole square plus 3 by 2. Okay, so this whole thing should be put in place of y, because g of y, what is g of y? This whole thing. So whatever you put in place of y, the same thing should come here in place of y. So here this whole thing will come in place of y. So what are we going to get? Minus 3 by 2 plus under root of, in place of y, this should come. So 4 into x plus 3 by 2 whole square plus 3 by 2. So this has been replaced in place of y and divided by 4. So when I multiply this 4 inside, then 4 will be there here and into 4 will come here. So 4 into 3 by 2, that will be nothing but 6. So here we have 6. So therefore this 6 and this 6 will get cancelled, and this 4 and this 4 also will get cancelled. So let me show you. Under root of. So when you multiply inside 4 into x plus 3 by 2 whole square, and you will have plus 6 here and minus 6 is there here. So therefore they get cancelled, and divided by 4 is there. This is getting cancelled. So we got this is equal to minus 3 by 2 plus under root of x plus 3 by 2 whole square. That will be x plus 3 by 2. Okay, so this is getting cancelled. So we got x. Again, I told you, whenever you are finding the composite function, you have to get it as an identity function, 100%. Okay, so if you're not getting it, maybe you can write it even if you don't get it also. In boards, you can do something and just finally you should get x. That's all. Okay, so therefore we got g circle f of x is equal to x for all x belonging to, x should come from the domain of f, and domain of f is n. So g circle f is an identity function on n. Next you find f circle g of y. So that will be nothing but f of g of y. What is g of y? G of y is minus 3 by 2 plus under root of y minus 6 divided by 4. Okay. Now you will understand why writing this as a perfect square is very important. If this will be replaced here, then you will have 4 into something very big, this whole thing square, plus 12 into this whole big thing, plus 15. And you will take at least 10 minutes or 15 minutes in solving all of it. But now, when you write it like this, it will become so simple. Just replace this whole thing in place of x. So 4 into minus 3 by 2 plus under root of y minus 6 divided by 4 plus 3 by 2 whole square. So this whole thing has come in place of x. Okay, and outside plus 3 by 2 is there. Okay, very good. So this is getting cancelled because this whole thing is in one bracket. So square is there, under root is there. So therefore, let me write the next part here. So under root and square will get cancelled. You will have y minus 6 by 4 plus 3 by 2. So this can be written as 4 into y by 4 minus 6 by 4. That is minus 3 by 2. Plus 3 by 2 is there from before. So therefore, we got 4 getting cancelled and this is equal to y. So we got f circle g of y is equal to y for all y belonging to domain of g, and domain of g will be S. So therefore, f circle g is an identity function on S. Okay. So this will complete step 4. In step 4, we have to take the composite function and that should come out as identity function. So I hope you you appreciate how simple it has become, because y we have written as a perfect square. Okay. So something square plus 3 by 2. So because of which the calculation will become much easier. And this is the method in which we have to do. Okay. Not the normal method where you put that big expression in terms of x here and proceed. Okay. So remember how to make a quadratic into perfect square. That is what is the importance of competitive exams. How do you make a quadratic into a perfect square? Okay. I hope you understood. Okay, so now step 5. Hence, f circle, first let us write, whichever one you want you can write. G circle f is identity function on domain of f, that is n, and f circle g is identity function on domain of g, and domain of g is S, implies f is invertible and g of y is equal to f inverse of y is equal to that expression that you got for x. X as some expression of y, you got it right? So something like this, minus 3 by 2 plus y plus under root of y minus 6 divided by 4. Something like this, just before you got x as a function of y. So this will be the completion of our finding the inverse function. Okay, fine. So the only difference here is how do you get x as a function of y? Sorry, how do you make the given function as a perfect square? And then you find x as a function of y. That is the only difference. Otherwise, everything else is exactly the same. And of course, one more thing, we got x is equal to minus 3 by 2 plus or minus under root of something, y minus 6 divided by 4, I think. So we have ruled out one of the definition because x cannot be negative, because x belongs to natural numbers. So this, in any of the question which comes in boards, you will be able to remove one of the possibilities very easily. And this multiple possibilities will come only when you have something like quadratic here. Okay. So when you see the domain, you will be able to clearly understand which one to remove and which one to take. Okay, got it? So therefore here we have taken x is equal to minus 3 by 2 plus under root of y minus 6 divided by 4. Okay, otherwise everything else is the same. Okay, I hope you have understood how to solve and how to find the inverse function and how to write in the board exam format. Okay. Okay, so now let us take some CET questions on inverse functions. Okay, so before we get into the inverse function CET questions, let me tell you some things which will be helpful for you when you are doing questions on, for CET on inverse functions. See here, we wanted to find the inverse function of this function. If the inverse exists, we have discussed before in the same lecture that the function should be both 1, 1 and onto. Correct, right? So as I told you, in boards, we will not be discussing, we will not be proving that the function is 1, 1 and onto. And once you have done this, you will find the inverse function. This is not the procedure for boards. Okay. So because you're not doing this, you are substituting this, means checking this or checking this, both are the same. So why it is same, let us not get into that for now. What I'm saying is checking for 1, 1 function and onto function is same as checking for this one. That is, if G circle F is identity function or not, and F circle G is identity function or not. Both mean, if you are doing this also, it means inverse exists. If you are doing this also and seeing if it is identity function, that means inverse of F exists. Okay. So after inverse exists, the answer is very simple. See, what I am trying to say is, this is to show, means all of this step 4 here, this step 4, this is to show that inverse exists, because this, whatever is the inverse function, which we are writing here, finally, okay, f inverse of y is equal to, the answer which we are writing here, we got it in step 2 itself. Okay, we got it in step 2 only, x as a function of y, right? If you are taking the, don't get confused, we are jumping here and there, but there is a one small point which you have to understand. Let us say if you are taking this function, f of x is equal to 4x plus 3. Now, the inverse function, if it exists, we found out the answer in step 2 itself, because y is equal to 4x plus 3. This is step 1. Step 2 is get x as a function of y. So x should be on one side and everything else should be on the other side. So 1 by 4 of y minus 3. Now, if you see in the solution of this question, finally, we are giving, this is the inverse function. So in step 2 itself, we got the inverse function. But in step 3, in step 4, step 3, we are just writing, let us define a function. In step 4, we are doing all of this just to see that g is the inverse function of f or not. Means, is f 1, 1 and onto or not? If f is 1, 1 and onto, inverse will exist. So there are 2 tracks here. Okay. One is you check for 1, 1 and onto. If the function is both 1, 1 and onto, inverse exists. If inverse exists, as I have shown you just before, getting x as a function of y, we got x is equal to 1 by 4 of y minus 3. This is the inverse function. Simple, over. You don't need to find out f circle g, g circle f and all. But for boards, you will not be checking this. So instead of this, what you will do is, you will calculate f circle g, g circle f, and see that these are identity functions. Okay. So therefore, inverse exists. Okay. But to find out this, I should know what is g. So g you are finding out by taking x as a function of y. Just before we have seen, right? Y is equal to 4x plus 3. So x is equal to y minus 3 divided by 4. So this I am defining as g of y. This is equal to y minus 3 by 4. So on the whole, what we have understood here is very simple. For competitive exams, go by this method. That is 1, 1 and onto, inverse exists, and this way. For boards, you take it this way. Okay. And g is nothing but, this one, y minus 3 by 4. This we got by finding x as a function of y. Okay, fine. So basically what I wanted to say is, we have the answer, that is inverse function, in step 2 itself. In step 3, step 4, step 5, we are just seeing if that is inverse function or not. That's all. Okay. So in boards format, if this is inverse function or not is checked by finding composite function and seeing if it is identity function or not. In competitive exams, you see if the original function is 1, 1 or not, onto or not. If it is 1, 1, if it is onto, then directly you have the answer. You want to find for y is equal to 4x plus 3. Just 1 by 4 into y minus 3. This is the inverse function. Simple, over. Okay, fine. So in competitive exams, how should you do? First step. Okay, for competitive exams, is this 1, 1 function or not? Okay. Let us say you got, it is not 1, 1 function. There is no need to check for onto function. Because inverse exists only if it is 1, 1 function and onto function. Even if it is, one of them is not happening, then inverse does not exist. Okay. So therefore, check for 1, 1 function. Whichever one is easy. Let us say for that question, onto function finding is easy. So check for onto function. If it is not onto function, that's it. Inverse does not exist. So if it is onto function, then check for 1, 1 function. If it is 1, 1 function and onto function, then inverse exists. Inverse finding is very easy. As I told you, just get x is a in terms of y. This is the inverse function. Okay, fine. So I hope it is clear that how to proceed for competitive exams, how to proceed for board exams. In boards, we know the method. In competitive exams, I told you how to write. Both are actually doing the same thing. Here you are seeing if it is g is inverse function or not. Here you are seeing f is invertible or not. That's all. Okay. So if you want to know why this is coming out as identity function, it is very simple. See, it is like this. If g is inverse of f, so when you are finding g of f of x, whatever f effect is there on x, if it is inverse function, this will reverse it. So whatever f does, inverse function does exactly opposite. So if f of x is equal to y, and if you are giving this y to g, then g will do exact opposite to f. So therefore, if f is taking x to y, g will take y back to x. So therefore, if you give y to g, then you should get back x. So that's why you are getting an identity function. Okay. Other way of saying is, whatever f is doing, g is nullifying it. So therefore, f is taking x to y. G is taking y back to x. So whatever f is doing, G is nullifying it. So therefore you're getting identity function. So that's why you're getting identity function. So that's what I said. If G is inverse of this function, if G is inverse of this function, then whatever f does, G will nullify. In the same way, if you're finding out f circle G of y, as we have seen just before, whatever f does, G does opposite to f. So G is taking y back to x. So in a way you can say whatever G does, f is doing opposite. Because if G is taking y to x, f is taking x back to y. So whatever G is doing, f is doing exactly opposite to f. If whatever G is doing, f is doing exactly opposite to G, right? So if G is taking y to something, f will take that to back again. So f of G of y. Okay. So if G of y is x, then f of x will be again y. So therefore again you will get an identity function. So that's all. So this is one way of seeing that, one is the means G is inverse function or not. As I told you, for competitive exams, 1, 1, on 2, invertible, f is invertible. So therefore you will go and see, what is the inverse function. When we do the problems, it will be very clear. Okay. So let us come to the problem solving. So here we have the first question. Let f is mapping from R to R, defined by f of x is equal to 2x plus 6, which is a bijective mapping. Then f inverse of x is given by. Okay. There are two things here. It is already given this is bijective. You don't even need to check. Bijective means what? Invertible. Bijective means 1, 1 and on 2. Means invertible. If this function is invertible, then finding inverse function is just 2 minutes work. 2x plus 6. Get x as a function of y. So y minus 6 is equal to 2x. So implies x is equal to half of y minus 6. So this is inverse function. So inverse function is equal to half of y minus 6. Now do we have y minus 6 here? Y is only not there. See, we want f inverse of x. F inverse of x means what? If you want to change this variable and write p, then you write wherever y is there as p. If you want to put p as x, put it. So f inverse of x is half of x minus 6. Simple. This function is saying whatever is there here, wherever this is coming, you put whatever is there here. If I want to find f inverse of 1, wherever y is coming, you put 1. If you want to find what is f inverse of p, wherever y is coming, you put p. If you want to find what is f inverse of x, wherever y is coming, you put x. So this is what we have. So x by 2 minus 3. Simple. Done. So this is given that this is a bijective mapping. This is saying that inverse exists. There is another way. That is, here we have all the options. A, B, C, D. In A, B, C, D, none of them means in A, B, C, D, all of them have answers. There is no option which is saying none, right? That means you don't even need to think. Inverse will exist. Otherwise, in 4 options, one of them is the correct answer. So all of them are saying some function. Means inverse will exist. Even if this is not given also, then also you can say inverse will exist. I will not check for 1, 1 and on to here. Because options are saying inverse is existing. There is an option, there is a function, you have to pick the function. So therefore, you don't need to check again, right? Just by seeing the options, you know that this is a invertible function. That's it, okay? Let us say, for example, one of the options is none. Then you should be careful because maybe this is not invertible. Maybe option D is correct because of that. Okay, fine, okay. So therefore, if in the question, if it is given, it's a bijective function, or it is an invertible function, or it is given inverse exists, or inverse exists. Inverse exists. Okay, bijective function, invertible function, or inverse exists. All of them means that the given function is 1, 1 and on 2. Okay. So after that, finding inverse function is very easy. Just get x in terms of y. So here we got this much. So that is what is f inverse of y. If you want f inverse of x, put x in place of y. That's all. Okay. So that is saying that inverse exists. The other thing is, if options A, B, C, D, all of them have some function, then you know that inverse exists. You just have to find which one is the right function. That's all. Okay. So I'm sure it is clear for you. Let us say, for example, this is none. Okay. And this is also not given. So we don't know if this is invertible. So how do you find this is invertible? We have to check for 1, 1 function and onto function. If it is 1, 1 or not, onto or not. Okay, to check that, if you know the graph, it is very easy. Graphically, it is the most easiest thing. You know the graph of this function. What is the graph of this function? It is a straight line. Okay, what else can you say? You can say that slope is equal to 2. Y-intercept is equal to 6. More than sufficient. Just draw the graph. So here we have y-intercept as 6. Means where it cuts the y-axis, that is 0, 6. Okay. Slope is 2. Positive slope will make acute angle with x-axis. Isn't it? Right? If it is a negative slope, then the straight line will be like this. Okay. If it is a negative slope, let us say, for example, if you want to draw a straight line with slope -2, then the angle it makes with x-axis will be obtuse. Okay. So here it will be acute. So that's it, simple. So maybe there will be a doubt. Why not like this? Why can't we draw like this? Then also y-intercept is 6. Perfect. But the slope is positive. So therefore, acute angle with x-axis. Perfect. Okay. Now we have the graph. What is the domain? All real numbers. What is the domain? All real numbers. So we have to consider the whole graph. Okay. Fine. So for the whole graph, you take any horizontal line, it never cuts the graph more than once. Okay. So therefore, this is a 1, 1 function. How to check graphically if it is 1, 1 or not? We have discussed in 1, 1 function video, NCRT video itself. Okay. So if you are taking a horizontal line, it never cuts the graph more than once. So therefore, this is 1, 1 function. Next, for all real numbers as the input, we have the whole graph. Okay. So let me come back. Let us do it once more so that it will be very clear for you. Okay. So I think it is better let us come like this. Okay. So here we have a straight line as our graph. The slope is 2. Y-intercept is 6. Because slope is 2, which is positive, this line makes acute angle with x-axis. Okay. And y-intercept is 6. So therefore, when you draw the graph, you should make sure that the y-intercept is 6 and it is making acute angle with x-axis. So therefore, this is the only way you can draw the line. Okay. Next is, always remember, we are interested only in the domain of the function. Whatever is the domain of the function, that is the input values. So we are interested only to see where the input values are there, right? We are not interested everywhere. So here input values are all real numbers. So whatever is the input values, first shade the graph for your input values. So all real numbers are my input. Input values are always on x-axis. So for all real values as your input, the outputs will be, means the part of the graph which you have to consider will be the whole graph. Because you are giving all inputs, you have to consider the whole graph. So first shade that. Okay. So this is the part of the graph which I am shading. Sorry, this is the part of the graph which I am interested in. Okay. Now you have the part of the graph which you are interested in. Okay. Next, we want to check for 1, 1 function. Okay. We know very well how to check graphically for 1, 1 function. Take a horizontal line. This line should never cut the graph more than once. That is the checking procedure, right? So therefore, you have taken a horizontal line. This line, you move it. Okay. It is never cutting more than once. So therefore, this is a 1, 1 function. Done. Next, how do you find onto function? Onto function, you will see if range of the function and codomain of the function are same or not. For the shaded part of the graph, what is range? Range is y values or output values. So here the y values. For this one, because this line is going till infinity, means it is going like this, it is going like that. So the lowest values of y will be minus infinity, highest values of y will be infinity, in between there is no break. So therefore all y values are taken. So implies range of this function is from minus infinity to infinity, all real numbers. Now you compare it with codomain. You compare with codomain. That is given in the question. Codomain will be given in the question. Domain will be given in the question. So when you compare range and codomain, clearly you can see range and codomain both are same. This is happening. Implies it is onto function. Okay, fine. So first draw the graph. Next in the domain, shade the graph. That is second point. Third point is for the shaded part of the graph, just take a horizontal line and move it like this. See anywhere it is cutting more than once. Nowhere. So therefore this is a 1-1 function. Done. For the shaded part of the graph, find the y values. That is range of the function. Once you have the range of the function, see the codomain. That will be given in the question. Compare it with codomain. We have range and codomain same. Means it is onto function. Means this is invertible. So if this is invertible, finding inverse function is just 2 minutes. Okay. So just before we have seen y is equal to 2x plus 6. Get x on one side, everything else on the other side. That will be your inverse function. Simple. Okay. So we have seen all of the cases. From the options, you can say inverse function exists if all of the options are given. In the question, itself, if it is given bijective function or bijective mapping, inverse function, okay, sorry, invertible, bijective function, invertible function, okay, invertible function, or it is given like inverse exists, all of them say that you need not check for 1-1 and onto again, okay, but these are not there, means then we have to check. Okay, let R be the set of real numbers and f is mapping from 0 to infinity to 1 to infinity, be given by f of x is equal to 3x square plus 1, then the set f inverse of 1 to 6 is, okay. So first of all, let us remove this part of the question. It is not at all needed for us. Okay. So this is our question. We have a function. We know the domain. We know the codomain. We know the function also. It is being asked f inverse of 1 to 6 is what? Very simple. See, if you have some function, okay, and this function you are giving, means generally you will give one value as the input, right? Here you are giving all the values of, which come from 1 to 6, infinitely many values, one by one you are giving and collecting the outputs. Okay. So you got some outputs. So let us say that is our answer only, right? This is what we need to find. Okay. So we got some outputs. That answer we should find. So how do we find this answer? Very simple. See, now again finding f inverse, that is not necessary. Because if you know the function, if these are the inputs, what are the outputs? That is easy. So, but we don't know f inverse, we should find f inverse. Why do all of that? Very simple. See, if f inverse is taking 1 to 6 to some y values, okay, here you have some output values. So, f of these values should be nothing but 1 to 6 only. Isn't it? F and f inverse do exactly opposite. So, if f inverse is taking these input values and giving some output values, then f of these values should be 1 to 6 itself, right? Okay, fine. So therefore, this we have discussed in inverse functions in the first, means starting of the video itself. Whatever f does, f inverse does exactly opposite. That's all. So there we have studied like this. If you are giving x to f, let us say if it is going to y, if you give y to f inverse, it will take back to x. If it will take back to x. Same thing here also. Okay. So now, do we know the graph of this function? Y is equal to 3x square plus 1. So this is very easy. Quadratic graph only. Just bring this here. So y minus 1 is equal to 3x square. So from here, x square is equal to 1 by 3 into y minus 1. So from parabola chapter, we know x minus, okay, let us write the general one. x minus h whole square is equal to 4a into y minus k is a parabola. Next, if a is greater than 0, it's an upward parabola. Okay, upward parabola. And if a is less than 0, then it is downward parabola. Okay, downward parabola. Fine. And vertex will be h comma k. Okay, so this is the point number 1 which we remember from parabola chapter. When you see like this or like this, this is special case only. This is special case where h and k are 0. So in general, if you see like this, x minus h whole square is equal to 4a into y minus k, then this is a parabola. First point. Second point is, if a is greater than 0, upward parabola, a is less than 0, downward parabola. What is a? A is nothing but, once you have 4 away, means 4 you keep aside, whatever is remaining outside the bracket, that is a. Which bracket? Where y is there. Okay. So next, if a is less than 0, downward parabola. Second point. Third point is, if you have like this, vertex will be h comma k. With x, you leave one minus sign, this much will be h, and with y, you leave one minus sign, this much will be k. So let us come here. So here we have, this can be written as x minus 0 whole square is equal to, okay, 4 into, I want 4 away, okay. So for that, I will, already 1 by 3 is there, I will put 1 4 into y minus 1. So therefore, 4 into 1 by 12 into y minus 1. This is equal to x minus 0 whole square. Now you tell me, first of all, this is a parabola. Next, is this upward parabola or downward parabola? It depends on this one. This is greater than 0. Okay, so let us write greater than 0. So this is an upward parabola. What is the vertex? 0, 1. So that's all. We have the graph. So let us draw the graph. Okay, so therefore the graph is upward parabola with vertex 0, 1. That's it. So now we have input values from 0 to infinity. 0 is here. Infinity is there. Input values are always on x-axis. So for these input values, what are the output values? These are the output values. Or this is the shaded part of the graph. Perfect. So now I want f of some set. Just before we have written, f of answer is equal to 1 to 6. So I want output values to be from 1 to 6. Okay. So what is this one? This is 0, 1 means this is 1 only, right? Okay. So let us write this as 1. It will be easier to see. So this is 1. So let us write 1 here. And here we have 6. So now we want output values to be from 1 to 6 for f of x. 3x square plus 1. Okay. For these output values, what should be the input values? That is very easy. For these output values, what are the input values? This, what are the input values? It is starting with 0. Okay. It is starting with 0 because I want these output values. So for these output values, I cannot take this part of the graph because this part of the graph is not there in our domain. In our domain, it is from 0 to infinity. So this is the only part of the graph I can consider. If I want from 1 to 6 output values, it can come only because of these x values. Okay. So what is this one? 1 is coming at 0. So this we know. Okay. So our answer, okay, this we are talking about, x values. It should start with 0. It should start with 0 and here you will get some number, right? So 0 starting answer is only 1. So option A is correct. Next, what should come here? Very simple. See, I want x value. Let us say this is some x coordinate x1. So for this x coordinate x1, y value is 6. So therefore 6 is equal to 3x1 square plus 1. So if you are bringing here, you will solve this, you will get x1 values. That's all. So here you will have 5 is equal to 3x1 square. So from here, x1 square is equal to 5 by 3 implies x1 is equal to plus or minus under root 5 by 3. Now I am sure you will be wondering, why did we get 2 values? We wanted only 1 value. Yes, we got 2 values because, see, we have taken this function. This function will give output value of 6 for 2 input values for this also, right? So this is also one input value for which output will be 6, and this is also the one. But we are interested the one which is there on the positive direction of x-axis. Sorry, which is there in the positive side of x-axis. So therefore, that will be with a plus sign. So under root 5 by 3. So therefore, here it will be under root of 5 by 3. Simple, right? What F inverse, we don't want to find F inverse here. Again, finding F inverse, even that way also you can do. There is nothing wrong in that. Here in this problem, both will take more or less the same time. You can find F inverse and then, then give the input values from 1 to 6 and find out the output values. Okay. So I'll just give you a brief how to do it after this, but without finding F inverse also we did it. So whatever is this answer, these are the output values. So F inverse is mapping these values to these values. F will map these values to these values. So therefore, that's it. You know the graph, and from the graph, you know the input values. You found out the input values for which output values are from 1 to 6. That's all, right? So if you have forgotten, then you should revise once again. What is a parabola? Parabola is a curve which looks like this. Next, if you have x square is equal to 4ay type, then it is a parabola. Okay. If you have something like this, then also it is a parabola. But here vertex is h comma k. Vertex is h comma k. Simple. Okay. Fine. And as I told you, based on the sign of a, means whatever is the sign of a, the same sign will be for 4a, because 4 is positive. So if a is positive, 4a is also positive. If a is negative, 4a is also negative. So therefore, in the previous thing which we have written like this, y minus 1 by 3 is equal to x square. So again, I need not make 4 into, this into 4. If you want, you can do it. But because of this 4, sign will not change. So therefore, I can leave it like this, and I need not make 4 here and write by 4. Because of this adjustment, sign of a will not change. A value will change because a value is not 1 by 3. That will be 1 by 12. After leaving 4, whatever is a, that will be the a value. But we are interested in sign of a. So therefore, sign will not change because of 4. So therefore, if a is greater than 0, upward parabola. If a is less than 0, downward parabola. Simple. Okay, fine. So there are other ways of doing it also. Let me show you another method. One method is finding F inverse. So y is equal to 3x square plus 1 and y minus 1 is equal to 3x square. So 1 by 3 into y minus 1 is equal to x square. For F inverse, we should find x as a function of y. So therefore, x is equal to plus or minus under root of 1 by 3 into y minus 1. And clearly you can see x should be positive. Whatever is this x should be positive or 0. So therefore, I cannot take with negative sign. I can do only this. Okay. But graphing this is very difficult. This is not easy. Graphing, finding the graph of this. Let us not get into this. This method will not work. Finding F inverse will not work. You have to do it using f of x itself. Finding the graph of this is not easy. Okay. There is, as I told you, there is another method. Okay. And that is always if you get f dash of x greater than or equal to 0. So if you are getting like this, implies f is increasing function. Increasing function means that as x increases, y increases. That's all. Okay. So if f dash of x is less than or equal to 0, implies f is decreasing function. Implies if x is increasing, y will decrease. That's all. Okay. So here, if you're finding f dash of x, then that will be equal to 6x. Okay. So these x values, see, x is always coming from the domain, right? So for our domain, x is 0 or positive. So implies this is positive. Implies f is increasing function. Okay. What I wanted to find, f of what values is equal to 1 to 6, right? More or less it is the same method. We are not drawing the graph here. That's all. Okay. So f of some values is equal to 1 to 6. Because it is increasing function means For, as I told you, as x increases, y increases. So if the highest output value for you is 6, means that will come when you put this x value. And if the lowest value of output is 1, then that will come because of this x value, because f is increasing function. For highest values of x, highest values of y. For lowest values of x, lowest values of y. That is what this is saying. As x increases, y increases. So if you decrease x, y also will decrease. That's all. Okay. So as x increases, means if you are giving highest values of x, you should get highest values of y. If you are giving lowest values of x, you should get lowest values of y. Same thing opposite. If you want highest values of y, that will come because of highest values of x. And for lowest values of y, you will get because of lowest values of x. And after that, it is very easy. So when will you get 6 as the output? When will you get 6 as the output? What is the x coordinate? So 3x square plus 1 is equal to 6. 3x square is equal to 6 minus 1, 5. Implies, just before we have seen, under root of 5 by 3 plus or minus. I can consider only positive values of x. So therefore, here it will be under root of 5 by 3. And you want the x coordinate for which the y value is 1. So 3x square plus 1 is equal to 1. So 3x square is equal to 0. Implies x is equal to 0. So you put 0 here. Okay. So understood, whichever method you want, you can use. Okay. Let us come to the third question. F is mapping from 1 to infinity to 1 to infinity. F of x is equal to x plus 1 by x minus 1. Then f inverse of x is, okay. So here y is equal to x plus 1 by x minus 1. I want to find f inverse of x. All the options are given. Very simple. So just find x in terms of y. So xy plus y is equal to x plus 1. So from here, get x terms on one side and everything else on the other side. Because I want x is equal to something. X as a function of y. Okay. So x should be there on the left hand side and everything else should be there on the right hand side. So 1 minus y by y minus 1. I hope it is clear. So 1 minus y and x into y minus 1. So from here we are getting this is 1 minus. So here we should have x plus 1 by x minus 1. So this is minus 1. So if this is minus 1, here minus 1 will be there. And so here there will be some change. So this is minus and here we will have minus and here we will have 1 plus y plus x into y minus 1 by y minus 1. So therefore this is x as a function of y. So implies f inverse of y is equal to y plus 1 by y minus 1. So what will be f inverse of x? X plus 1 by x minus 1. So x plus 1 by x minus 1, option B is the correct answer. Simple, right? Let us go to the next question. So here the inverse of the function, this we need to find. Given inverse exists. It is already given inverse exists. Here all the options are given, so no need to check. Okay. How do you check? That is not needed now. Okay. How do you check if this is invertible or not? This is not needed for, we will discuss that little later in other chapters. Is this 1, 1 or not? So, or is this onto or not? Checking for invertible is, not necessary here. All the options are given. But if you want to check, then, we have to discuss a lot of things which we have discussed in IIT JEE part. That is either finding f dash of x, okay, finding f dash of x, and from here proving that this is 1, 1 function. And from there itself, you can prove that this is onto function. All of these we have discussed in IIT JEE part. For now, for here, it is not so much needed. Okay. So let us go ahead and take the next question. Here, all the options are given. F inverse exists. Simple. Okay. The inverse of the function y is equal to 10 power x minus 10 power minus x plus 1 by 10 power x plus 10 power minus x. So this is very easy. Inverse exists is already given here. So just get x as a function of y. So let us first write it like this, because 10 power minus x is 1 by 10 power x divided by 10 power x plus 1 by 10 power x plus 1. So after this, just take LCM here, 10 power x into 10 power x, that is 10 power 2x, minus 1 by 10 power x, divided by 10 power x into 10 power x is 10 power 2x, plus 1 by 10 power x, plus 1. So numerators, denominator are getting cancelled. So after this, y is equal to 10 power 2x minus 1 by 10 power 2x plus 1 plus 1. Take LCM. Now what is our main intention? To get x is equal to something, x as a function of y. So for that, 10 power 2x minus 1, okay, plus 10 power 2x plus 1. So we are getting y is equal to 2 into 10 power 2x divided by 10 power 2x plus 1. Let us get all x terms on one side, everything else on the other side. So y into 10 power 2x plus y is equal to 2 into 10 power 2x. So we want x terms on one side, everything else on the other side. So therefore, let us bring this here and this there. So therefore, 10 power 2x into y, so y minus 2, this is equal to minus y. So from here we have 10 power 2x is equal to 10 power 2x is equal to y by 2 minus y. So take log on both sides, log to the base 10 is equal to y by 2 minus y. So this 2x will come down. So from here we have 2x is equal to log to the base 10 y by 2 minus y. So therefore x is equal to half of log to the base 10 y by 2 minus y. So after this, it is very simple. If you want to find f inverse of x, then half of log to the base 10 x by 2 minus x. So that will be option B. So very simple. That is how we have discussed CET questions also.